Welcome back after the break, and let's quickly continue looking at question 1.5, figure 1.5 in the sketch of a river system. Now, I've added some information over here without looking at the question first. Now, as you can see, the river starts from its source all the way to the mouth. And this area over there looks like a delta. Now, the rivers joining the main river, as you know, is known as tributaries. What separates one drainage basin from another is known as the watershed. It's a high-lying area. Now, the high-lying area at A is the interfluve. What does it do? It separates the tributaries. Now, very importantly over here, we've learned in geomorphology that we can divide a river into three sections. Now, if you look at this overview, am I right if I'm saying that this area over here is your upper course, this is your middle course, and that's your lower course. Now remember, matrix, the upper course, extremely steep, downwards erosion. The middle course is not as steep, but the volume of water increases. There's lateral erosion taking place as well as downward erosion. And as you can see over there in the lower course, it's a gentle gradient. There's only deposition taking place. As you can see, the river starts to meander, and when we look at meandering, you've got your cutoff and slip-off slope as well. But now let's just quickly go and look at the questions. Name the high reach labeled A. Go back to it. This is the high reach over there. Now what does this high reach do? It separates this tributary from this tributary. So what is that high reach called? It's known as a interfluve. Now what purpose does the high reach serve? Like I've already mentioned, it separates the two tributaries from one another. Explain two natural factors that could influence the stream flow of the river system, 1.5.3. Now, when we look at the stream flow, that's our first topic. It was our first topic when we looked at geomorphology. It can be surface runoff or it can be underground runoff. So what can influence that water is going to be on top of the surface or is going to infiltrate to below the surface? Now, if we look at, let's say, a drainage pattern, we look at two dendritic patterns, as you can see. There's a dendritic pattern A, and let's call this dendritic pattern number B. Now, obviously, if you look at dendritic pattern A, it's got many more tributaries. So if I'm saying, if you look at comparing A to B, which one experienced more surface runoff? A. And B experienced more underground runoff. Now, what's the factors influencing that A experienced more surface runoff and B experienced less? And we looked at it when we looked at the geomorphology section. First of all, and this is going to answer our question in question 1.5.3. We can say that drainage basin A experienced higher rainfall than drainage basin B. So we can say that drainage basin A experienced higher rainfall, permanent rainfall during the year, and drainage basin B only experienced seasonal rainfall. Another reason is the type of soil that's where this river is flowing. And we can talk about the type of rock as well, the permeability of the rock. Now, we've discussed it. When a rock is permeable, what does it do? It allows the water to infiltrate. When a rock is impermeable, it doesn't allow any of the water to infiltrate. If we look at drainage basin A and drainage basin B, would you say that drainage basin A will have a lot of vegetation? No, because there's more surface runoff, there's more tributaries. B might have more vegetation, because what does vegetation do? It promotes infiltration. Another reason, another factor that plays a role is the steepness of the gradient. For instance, if you look at the drainage basin A, we can say that it's on a steep gradient because the water don't have time to infiltrate. Comparison to drainage basin B might be on a flat gradient and the water rather infiltrate, and that's the reason you will see less tributaries. So there will be less surface runoff. Now let's quickly go back to our question. Explain two natural factors that could influence the stream flow of the river system. The amount of vegetation, the amount of rainfall, type of underlying rock, and you can say the steepness of the gradient. Now keep in mind, I've only asked you to mention two. I gave you four factors that explains it. Explain the formation of the delta at B in figure 1.5. So let's quickly go back to the diagram over here. As you can see, this area over there is clearly a delta. Now explain the formation of the delta. Now what happens in the lower course, grade 12s? Is there any erosion taking place? No. Deposition. All of the eroded material from the upper, from the middle, are being deposited in the lower course. So what basically happens to this river? It loses its energy. It starts to flow sluggishly. So all that material are being dumped, deposited down there. And that's the reason all the sediment are being deposited where the mouth is and creates the delta formation. Now, very simple as well, explain the formation of the delta. It's the ultimate base level of erosion. As you can see, the river can't erode further where the mouth is. So we can say that. So all the sediments are deposited over there. And the mainstream splits up in smaller tributaries as it where it flows, where it's deposited, as you can see in this diagram over here. Because of all the deposition, almost looks like a braided stream, but unless the braided stream usually we find in the lower course, but where the delta is because of the amount of deposition taking place. So what can we write over there? We can say that because of deposition of all the sediments from the upper and middle course, and we can say because it's at ultimate base level, it can't erode furthermore. Now state two advantages of farming in area C. If we quickly look where area C is, it's next to the river in the lower course. Now one correct answer definitely is it's very fertile soil. It's rich in nutrients. And another reason, it's close to a water source. We can use it for irrigation purposes. Okay, that's your answers to question 1.5.5. Now 1.6 is a case study about the Umgeni River in KwaZulu-Natal. Now, if you quickly read with me, in the Umgeni River is in KZN. The Umgeni River is one of the dirtiest rivers in the country, with recent studies showing proof of cholera, salmonella, Shigella, and other harmful viruses, of bacteria that's found in the Inanda Dam and the Blue Lagoon in Durban. The release of the study comes after the city's health unit has raised the alarm over a suspected outbreak of diarrhea. 2 children has died and 150 people were hospitalized in the last 3 months. Though they did not pinpoint the exact pollution sources, the researchers suggest that the most likely sources of the virus and bacteria in the Umgeni are inadequate because of sewage by municipal sewage treatment and runoff from the informal houses close to the river. No wastewater treatment is provided, and raw sewage enters the rivers and streams directly. Because of a lack of infrastructure in some settlements, the residents are often forced to inhabit river banks. Now, this is the case what happens in informal settlements. An informal settlement is an area, is a settlement that lacks basic needs and services. For in this case, they lack sewage. So what happens? They live on the banks of the river, they wash their clothes over there, excrement goes into the river, and what it basically does, it pollutes the river. And it can create serious illness when people drink the water or use it for washing or even cooking. We can't use it for recreation, people can't swim in it because it's very dirty. Now let's quickly look at the questions that follows regarding the Umgeni River. Name the human activity that's polluting the Umgeni River, and the blame is on the municipality with their sewage system. Now, what evidence in the case study suggests that the Umgeni River is dirty? 2 children has died. The viruses that they detected over there was diarrhea, cholera outbreak, and leads to 2 children that passed away. And 150 people being hospitalized. State the negative impact of the dirty water and the quality of life of people living in the area. Now, first of all, we won't be able to use it for recreation. Another reason is it might be a loss of income, because people might use the river for recreation, but now no one is allowed to go there because they're scared to be treated with some sort of virus. It can cause an outbreak. That's another problem. It can cause an outbreak. And people can't work close to the area. Okay, now your next question is also a paragraph question that we need to have a look at. Remember, only answer this question in paragraph format. I'm going to use bullets, but keep in mind that you need to ask this in a paragraph format and do not write your answer in bullets. Suggest strategies that could be put in place to reduce the negative impact of humans on the Umgeni River. Now, first of all, stricter control and legislation from the department. So fines needs to be implemented. People who pollute the river, and stricter control to not pollute the river and use it to wash their clothes and pollute the rivers with their rubbish. So they can use fines for imposters as a punishment so they don't pollute the river any further. Improve waste facilities. So instead of using dumping grounds close to the river, have allocated areas where people can go and throw their rubbish away, and maybe recycling points. Another initiative that we can use, regular testing of the water. Regular testing of water to make sure the water is safe. So that's the strategies that the government can put in place to make sure that the Nguni River can get cleaner as we move forward in the future. Next time around, we're going to look at question number 2. I hope you've learned something over here. Thank you very much for watching. See you next time around.